Greetings to all. This is Dr. R. Ravikumar. In this video, I would like to discuss about recursion in C language. What is recursion? Simply, recursion means function calling itself is called recursion. So, recursion is a programming technique where a function call itself. A recursive function solves a problem by breaking it into smaller subproblems. Okay, so once again, what is recursion? Recursion means calling the function itself. Calling the function itself is called recursion. Now, key concepts of the recursion. Every recursion should have base case, base condition. If you forgot to write the base case, that function calling it itself will yields to infinite iteration, infinite calls, which due to that we may not get the result. So what is the mandatory one for every recursive function? Before writing the recursive function for that problem, we have to identify what is the base condition to stop the recursion. And the second one is recursive case, that is when we have to call the function itself. These two we have to identify. Okay. First point, once again, if the first point is missed, that is where we are unable to find out the base condition. If you call the function itself, then it will enter into the infinite loop. Now, why use recursion? It simplifies the complex problems like towers of Hanoi problem. For such problems, it will be easy to write with the recursion than the non-recursive functions. These are useful, this recursion is useful in trees, graphs, and as well as divide and conquer problems. So quick sort, merge sort. In such problems, we are going to be use recursion. Code becomes more readable. That is, in the binary search trees or in binary trees, to traverse the binary search trees, we read recursive functions. More readable. We can understand it easily by using the recursive function. General structure of the recursive function. As usual, it is also a recursive function is also a function, so it should have the function name. It is going to be have the parameters as well as it should have the return type, and this is the function body. In the function body, we must contain the function call of the same function name, and this is also same function name we are going to be call. Then this will jumps to here. Now it is forming a loop iteration. Recursive call will forms a loop. So how many times, up to how much time it has to be iterated? So there should be an end. For that purpose, it is mandatory to write a base condition to stop the recursive. That is, if this condition is true, then we are stopping the recursion. Otherwise, we are calling the function itself. This is called recursion. This should be the way of defining the recursive function. Now example for factorial using recursion. Generally, what is factorial? Let it be 3 factorial equal to generally 3 into 2 into 1 into 1 or into 0 factor. What is 0 factor? It is mathematically defined as 1. So nothing but you are going to have 6 as the answer. Now, whereas coming to this recursion, what if I ask find out the factorial of 3 factorial is nothing but 3 factorial equal to, I am going to be right, I know 3, but what should be multiplied with the 3 means 2 factorial value should be multiplied. What is 2 factorial? Now we have to find out what is 2 factorial. What is 2 factorial? 2 factorial equal to 2 into 1 factorial. Now here, what is unknown? 1 factorial. Find out what is 1 factorial. 1 factorial equal to 1 into 0 factorial. What is 0 factorial? 0 factorial is mathematically defined as 1. Now, if you observe this, I am going to be replace this 0 factorial value 1 here. Then it is going to be replaced by 1. 1 into 1 equal to 1. That is the answer of 1 factorial, it is going to be replaced here. Then 2 into 1, that equal to 2. That is the 2 factorial value, it is going to be replaced here. Then 3 to the 6 is the answer of 3 factorial. Now, if you observe this, how we are going to be solve this means, to find out the n factorial value, we are going to be write n into n minus 1 factorial. That is what all these three recursive equations are saying. Now, if you observe this particular task to solve this, so instead of finding this n minus 1 factorial, here we have defined the function called fact of integer n. Now, this function is going to be called as fact of, let it be 3. If I call this function from the main like this, then this 3 value will be copied into n. And what is the n value now? Is it equal to 0? No. Then in such case, we are calculating n into, that is, what is the n value right now? 3. 3 into, as I said here, 3 into fact of 3 minus 1, that is 2. Fact of 2 means nothing but again a factorial function call. Then from here the control will goes to here. Now what is the n minus 1 value? 2. That 2 value has been copied into n. Now whatever the previous n value, that value will be stored in the stack. When first time it is called, what is the n value? When first time it is called, what is the n value? Means n value is 3, and here what we are calculating? 3 into fact of 2 we are calling. Now function came to the control came to the beginning of the function. Now what is the n value? This time n value is 2. What we are calculating? 2 into fact of 2 minus 1, that is 1. Again it is a function call, same function calling itself, recursive function call. Now what is the n value? Now it is 1. So n equal to 1. Now it is going to be calculated fact of 1 into fact of 0. Now what is the n value? Now again we are calling the function n minus 1. N minus 1 means 1 minus 1, 0. We call this function. What is the value in the n? 0. Now that 0, n equal to 0, yes, it met this particular base condition. Now what we are doing? Return 1. This value will be returned to where? Previous, from where we came here. Right now n value is 0. From where we came to here means from the case when the n value is 1. When the n value is 1, what we would like to evaluate? We would like to evaluate 1 into fact of 0. Now what we have written? N equal to 0, written 1. That is the answer of this fact of 0. I am changing the color. Yeah. Now, right. This factor of 0 has been replaced by 1. 1 into 1 is 1. That value, what we are returning? Return. Now, in this case, what is the n? In this case, what is the n? 1. Now, that value has been, 1 into 1 is 1. That value has been returned. Return means, so what is the next step? N value, where is that? N equal to 2. Now, 2 into factor 1. Right now, we evaluated factor 1. What is this value? This value is 1. 2 into 1 equal to 2. This value is going to be returned. Return means where it has to go. It will goes to the previous call. Previous call, what is the n value? 3. 3 into factor of n minus 1, that is 2. Factor of 2 is 2. 3 into 2, what is the answer? 6. Will be returned to the main function from wherever we are calling this. This is how a recursive function call is going to be executed. Same thing, as I already explained. What is factor of 4? 4 equal 4 into factor of 3. What is factor of 3? 3 into factor of 2. What is factor of 2? 2 into factor of 1. What is factor of 1? 1 into factor of 0. What is factor of 0? This is meeting, this is equivalent to the base condition. So we are getting the one value that has been replaced here. Now what is the value? 1 into 1. That value has been written to here. Then 2 into 1. That value has been written to here. 3 into 2. That value has been 3 into 2 is 6. That value has been written to here. Now 6 into 4. 24 is the factorial of 4. This is called tracing. Now, evaluation. Evaluation means from where we evaluated. Do you evaluate directly factor of 4? No. Do you evaluate factor of 3? No. We evaluated from the base condition. What is the base condition? Factor of 0. So that is the thing. Factor of 0 equal to 1. It has been replaced here. 1 into factor of 0 we replaced here. And then this result has been replaced here in place of factor of 1. And 2 into 1 is the result of factor of 2 that has been replaced here. 3 into 2 6. It has been replaced here. Finally we get 24 as the factor 4. Now call stack. Yeah, I already represented that. Now advantages and disadvantages. This is the elegant solution for the recursive problem. So in most of the problems, like as I already told you that, towers of Hanai problem and towers of Hanai problem and binary search tree traversals. In all the cases, we required to write the code by using recursive. Easy to understand the logic. It will be very easy to understand the logic. What are the disadvantages? It uses more memory from the stack. So in such case, if we forget to write the base condition, we will get the error even while writing the recursive function. We will get the error like stack overflow. Stack overflow. When we are going to get such error means if at all the base condition is not met, then it will reach the stack overflow condition. Slower than the another disadvantage is slower than the iteration in some cases. Iteration means loops. Loops it is very slower than the compared with the loops. And recursive what's this iteration? The recursive uses function calls, requires more stack memory. That is those are the disadvantages of the recursion. Now iteration uses loops as well as more memory efficient. That is simply to evaluate the same factorial of n, what we are going to be write for I equals to n, I greater than 0, I minus minus. Initially I will take a f equal to 1 where 1 is the multiplicative identity. F equal to f into I. Now what is the value? I value initially n, let it be 4, I value is 4, f value is 1, 1 into 4, 4 has been assigned to f, then I minus minus 3, 3 greater than 0. Again multiply with the f. What is the f value means 4. Now 4 into 3. 4 3 is 12 has been replaced here. Now again I minus minus 2. 2 greater than 0. Yes. Then 2 f is 12. 12 into 2. 24 we calculated and it has been assigned to f. I minus minus 1. 1 greater than 0. Yes. 24 into 1. 24. Yes. It remains same 24. And then I minus minus 0, 0 greater than 0, false, we came out from the loop. What is the f value now? F is having the value 24, is nothing but 4 factorial value. So here only logarithm simple loop where how many times we are iterating n times. So there is no usage of stack, internal stack. That is advantage of loops. But recursion, why we require recursion even though it is very complex, it is readably very easy readable, and some problems we can solve only by using recursion, such divide and conquer problems. Okay, hope you understand the concept. Now recursion conclusion. Recursion is powerful when used correctly. If you don't use correctly, it will lead to a stack overflow, such type of problems. Always define proper base case, otherwise again you will enter into the stack overflow condition. Understand tracing to avoid the errors. If you trace it, you can easily identify where the error was occurred. So hope everyone understand the recursion.